Hello, my name is Zach, also known as Dumb Bird. This is where we left off last time as far as code goes. We drew a little rectangle in the top left corner of the screen. That looks like this. Our goal of today is to get a ball that actually bounces around the screen. So it'll come down and it will bounce around. Alright, so I actually go to implement this. Before we do anything though, I want to take my rectangle here and I want to actually make a ball struct out of it. So outside of my main function, I'm going to create a struct called ball. And I'm assuming you understand basic structs and stuff like that in Zig. We're going to need a few fields. Of course, we're going to need our position. We're going to need a size, and we are going to need a speed. Let's go over the types of these now. So the position is going to be a vector2. This is something provided to us by Raylib. A vector2 is just a point. That means it's your xy. And using it is also pretty simple. For example, I could just do position.x or position.y, so it's really convenient. All right, so now we have a size, which, seeing as our shape is a square and it has the same width and height, you would think this is just a float 32, and you wouldn't be wrong, but we're actually going to make this a vector2, and the reason why will become apparent later on. The speed, same sort of business, could be an F32, but the reason we can't do this, even though the speed is constant, it's because the direction is not. So what I mean by that is if we actually run this build, we look at our square, and let's just run through the motions of the ocean. So if we have our square moving in a positive x, positive y, and remember that going positive in y means going down, because 0, 0 starts in this top left corner. So we'll follow the square down, and the square would go down to like here. And then when it bounces, we still want to be going in this positive x direction, but we want to go in the negative y now. All right, so now that we know that we need to store this as a RL vector too. All right, we're going to implement 3 methods on this ball, at least for now, only 3. And we're going to implement a init function. We're going to implement a update function and a draw function. So I'm gonna quickly go over these few functions. We have the init function, which is just a convenient way of creating a ball struct without having to do it all manually. Updates values, whether that be your position, speed, or whatever it may be, and your draw. The reason we separate update and draw is because sometimes you just want to update where the ball should be and all that other stuff without actually drawing it yet. All right, so now what we're going to go ahead and do is implement these things. So we have our init. First, we're going to take in some values. Let's take in an x, which will be a float 32, along with our y, which is the same. Let's take a size, which will also be a float 32, and a speed, float 32. The reason we're using float 32 here is because vector 2s take float 32s. So pretty simple. All right, so to actually implement this function, we're going to return a ball and dot position. There's an autocomplete, that's cool. Dot position is equal to rl.vector2.init. So this actually creates our vector2 with our x and y values. And now we'll do a size, which is the same sort of thing, a vector2.init. And since it is the same width and height, we can do size. The same sort of idea applies for our speed as well. And give it a speed. All right, there we go. That's pretty much our init function. Let's just make sure that this returns a ball. And there we go. That's our init function done. Now for update and draw, these both need to take the ball as an argument. Zig has a convenient way of doing this where you can actually just reference the ball like this as self. And then you can actually use all the methods in it or whatever. So self.position, for example, would be the position. Right now, we're not going to do anything with update, so let's actually ignore the self variable, or else Zig will get mad at us. Let's also make sure to add the return type here, which is void, and same with our draw. Draw is also just going to take that single argument ball. There we go, and boom. So let's just go ahead and copy over our draw function here, slap that in there. Now we have our draw rectangle. Once again, it takes in, just a recap from the last video, is it takes in an x, it takes in a y, it takes a width, a height, and a color. So that's all cool, that's cute and beautiful, But this isn't really what we want to do because there's actually an easier function for what we're doing now. As you can see, our position is a vector too, and we don't really want to do self.position.x and self.position.y. What we can actually do, though, is do a function called draw rectangle v for vector. So draw rectangle v takes in the position as a vector, the size as a vector, that's why we have as a vector, not a float 32, and the color. So let's go ahead and just do that. We'll implement add some values in there. So come down here. Self.position for our size is self.size. And for our color, we'll just have it as red. So if we have this all right, we should be okay to actually start using this now. So to actually use our newly created struct, what we're going to do is we're going to jump down here and create a var. Now the reason that we're not making it a constant is because, well, when we get to implementing update, we're going to be updating the position, so it can't be constant. Regardless, we're going to make a ball and do ball.init. And now if you remember, our init function takes in an x, y, size, and speed. That's not what I wanted to do. So we can give it an x of 0, a y of 0, the size of 32, so this would be 3232. And the speed of which right now we can just set it to 0 because we're not moving the ball yet. All right. Before we're done, we actually have to draw this ball. So let's do ball.draw. Oh, jeez. .draw. Okay. So there we go. That should be all. If we save this and we run it, we should have the same thing that we had before we started or at the start of the video. And we do. So this is all good. We have just separated the code into a struct. Very convenient. To finish off this video, we're going to actually add some movement to this. So to add movement to this ball, we're going to have to add our speed. Seeing as position and speed are both vectors, what we can actually do is we can just add them together. So self.position equals, equals self dot. Okay, wait. So let me actually explain something here. Just to be cool, we're going to be using the Raylib math part of Raylib. But you don't have to. If you do not want to use that dependency, which comes with the Raylib bindings for Zig, what you can do is do self.position.x plus equals self.speed.x, and you can do the same process for the y. Because I want to show you how to use Raylib math or how to import it, I'm not going to do that. So this is more of a learning opportunity. So I'm going to make a constant called RLM, and we're going to import Raylib math. So Raylib math can be imported by doing raylib-math. Okay, now that we have that, we're going to set position equal to rlm.vector to add. So this adds together two vectors as you see here. So we're going to add together our self.position and our self.speed. All right. Now, we actually got to add some movement because, well, first of all, we don't have the update here, and we also don't have a speed value. Let's give a speed value of 4 because that's 4. We'll do 4. And what we're going to do is we're actually going to do a ball.update. So we have to update our position before we draw, and that's that. I guess one thing I'm going to add right now for convenience is I'm going to come here, I'm going to do updates. Just update and draw. I like to section off my main game loop into updates and draw calls because it's convenient. Alright, now after all of this, if we run this, we're going to see something strange. It's moving, but what the hell is happening here? Like, look at what's happening. Okay, I have a simple way to answer this question. Actually, this is something I left out in the prior videos for a reason, and this is this reason. We actually have to call rl.clear background. This is because every single time you draw the frame, it doesn't automatically clear. So we're going to clear with a color. In our case, we're going to clear with black because it's Pong and just black and white. This can be any color you want, though. Now, if we rerun this again, we have ball movement. The final part of this video is to actually add collision. So we're going to head into our update function here. We're going to do that now. Adding collision isn't as scary as it sounds. Actually, it's pretty simple. Nope. What we're going to be doing is just checking if, for example, on the y, if y is 0, then we already know that we are checking, or we already know that we're at the top. If we're at the bottom, that's just the width of the height of the screen, and that same sort of logic applies for your x as well. So let's go ahead and do that. So let's check for our y first. So check for y collisions. We'll do an if statement here. So if our self.position.y is equal to, or sorry, is less than, or is less than 0, less than or equal to 0, then we know that we are touching the top of the screen. So we can do this, check for our top, and if we're here, what we want to do is do self.speed.y times equals -1. I'm sorry for being boring. This part is going to be boring because, well, it's boring code. All right, so now that we have this shebang, what's going to happen is when we touch the top, it will bounce off. We don't have stuff for checking the bottom yet, though, and that's a little bit harder, but we'll do that now. One thing I'm going to quickly explain, though, is when we look at an actual cube, the issue is that the origin is at the top left of that cube. So this top collision works because this cube here, the top left corner is going to smack the top before anything. But if we're going down, we have to actually add the height of the cube to get the down direction, if that makes sense. But I'll just show you that now. So self.position.y plus self.size.y. This is what we have to do to make sure that we are getting the right point to check. All right, so now we're doing this. We will check if this is greater than or equal to the screen height. All right, cool. And now you'll see, if I run this again, and we take a look, hopefully this bounces off the top and bottom. Bounce, bounce. Really neat. The only thing we're missing now is x detection, the checking of the x axis. So let's do that here. Check for x collisions. All right, and if self.position.x is less than or equal to 0, or self.position.x plus self.size.x is greater than or equal to screen width. All right. So now we do the same sort of thing. We do speed.x though this time and times it by -1. This is all we need for the collisions. And now actually running this, we should be able to see that we have a ball that bounces around on all the walls. Boom, 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 boom. That's going to be it for this tutorial. And watching the next video, we should hop in to drawing paddles. All right. I'll see you then.